Hey guys, I hope you're well. Boy, am I nervous. I'm trying not to giggle. I've got the giggles, man, because it's been so long. This always happens. It's nerves, don't you see? I hope you've been well. I have not. And my older sister, Carol, who's 14 years older than me, she fell down and got pinned under her chair and wasn't found for 3 days. And she hit her head on the way down. She had bleeding. She has a blood clot on her brain, and that's all we know right now. She had her MRI today. She's been in the hospital for 3 days. So let's talk about my 50 ohm attenuator pad that I'll be using for my QRP and QRPp exploits, which you'll be seeing. I haven't been operating much because I want to get on with things. I want to play with 100 milliwatts. I'm on a mission. I'm going to have more fun than I've ever had in my ham radio 49 years, man. And I can't wait. Well, I shouldn't say that now. I worked southern Argentina with 2.5 milliwatts and got an honest S7 on 15 meters. That's having QRPpp fun. Right? So I've got the parts ordered for my 50 ohm attenuator pad, and it will offer both 10 dB power reduction and 20 dB power reduction. I'm going to input 10 watts 10 watts PEP single sideband and 5 watts RMS CW. I'll input 10 watts, and using the 10 dB output, I'll get a power out of 1 watt. Using the 20 dB port, I'll get a power output of 100 milliwatts, 1/10 of a watt. Now I'm going to zoom you in one moment. The schematic I found that I decided to use suggested these resistor values right here for the 20 dB version and these resistor values for the 10 dB version, okay? And they went on to suggest a common value of 56 ohms rather than 63 and 270 ohms rather than 257. And for the other one, it requires a 74 ohm resistor, and you can get a 75 ohm resistor, and also it requires 100 ohms. So that one's a given. Okay. I started looking at this 257, huh? Well, you can do way better than that, than 270. I'm going to zoom you in and we'll look down here. Okay. Hang on. Okay. Improving accuracy. For the one that required 63 ohms and they suggested 56, well, if you add another 6.8 ohms in series with it, you get a value that's only 0.2 of an ohm off of what they require, okay, or what it was designed for. And for the 257 ohm resistor, well, if you parallel the 270 with 5.6K, you get 257.5. Okay, it's only a half an ohm off of what their design calls for. And then I started thinking, well, what about accuracy? What's the accuracy of this thing? What if you connect 50 ohms to the input port? What kind of output impedance will you see? Okay, and I want to show you something on the schematic again. Hang on. See, guys, what you have here, when you want to calculate these impedances, it's very simple. What's the input impedance? That's the question. What is the input impedance? Well, it's very simple. You've got this resistor in series with this one, and that combo in parallel with this one. It's simple math. And using my spreadsheet, it's no math. Maybe I'll show you when we're done here, okay? And looking the other way, it's a bidirectional. It's balanced. It's a bidirectionally balanced attenuator. Doesn't have to be. This pi configuration can transform any impedance to any impedance, basically, within reason. But anyway, looking back at it this way, it's the same thing. This resistor in series with this one, that combo in parallel with this one, okay? And it just so happens, I pause you and see when I was thinking about it, we had mitigating factors. One of them being the common value of 56 ohms they suggested instead of the 63 ohms. Well, it's 12.5% low. On the other hand, the 270 ohm resistor common value, it's 5% high. They're not additive, they're subtractive. They buck. And I suck. One moment. Okay. As the error, the overall error I found with their design values was 5%. As designed, with an input of 50 ohms, the output impedance is 52.5 ohms. 5% error. 52.5 ohms. 5% error. I started thinking, well, what if I don't correct the values? See, this is with me correcting the values of the common value resistors to the actual required ones. Sorry about getting so flying around with my pointer, but I'm worked up. I do love to bullshit electronics, especially in terms of QRPp, especially in terms of QRPp CW. But I digress a little bit, I do. Well, what if I used the common values? Well, if I apply 50 ohms to the input, I'll get an output of 47.8 ohms. It's the other direction. It's a little lower than 50 ohms. But what's the error using the common value resistors? 4.4%. If I correct the resistors to the designed for values, the error is 5%. I'll go with the common value resistors. And less parts, better accuracy. Hang on. I feel stupid. I pause you. Come on, phone. I'll pause you one moment. Now you have had your lid closed, right? When you, oh no, not when you're watching me. I guess you gotta have it open. I hope you watched me so far. I hope you watched me so far. I was going to show you my spreadsheet. We're 7 minutes and 57 seconds in. Hang on. I pause you. I show you. Okay, guys. I hope this goes okay. My mouse is really wonky lately. My N8NK unit spreadsheet. Let's take a scroll down. At the very bottom, I have a parallel resistance calculator. Where'd it go? Series C, parallel R, value 1. Okay, as they're designed for their 20 dB version. Let me put my glasses on. Have you got Moyer pattern? Is it Aerosmith that sings No Moyer, No Moyer? I'm sorry, man. Hang on, we're going to zoom you in. Man, this Moyer pattern is truly evil. Well, let's input the values for the 20 dB version for the resistors, okay? In effect, what you had there was, no, let's go with the 10 dB version. The math is easier to use. They suggest resistances of 75 and 100 ohms. So what you had here, you had 75 plus 100 in parallel with 100, okay? Am I right? Yes, I'm right. 75 plus 100 in parallel with 100. So you have 175. Okay, this is better. Things weren't computing. Let's try that again. In the 10 dB version, you have 175 ohms. That's the value of those two resistors in parallel with 75 ohms. And that gives you a total resistance of 52.5 ohms. Okay? And similarly for the 20 dB version. I like my spreadsheet. I like it a lot. If anyone wants it, you can have it. One moment, I pause you. And I keep bumping things because I'm nervous. Hi, Blitzy. I love you. So I babbled long enough. I guess that's about all I have to say about my QRP and QRPp attenuator pad that I'm going to build as soon as the parts get here. It'll just be a simple metal box with 3 BNC ports, an input and 2 outputs, depending on which attenuator you choose within that box. And a switch to select between the two, right? I hope you're well. Yeah, I was going to talk about another bit of electronics. I'm not even going to uncover it, but my aquarium auto top-off controller is done. It's designed, it's built on the PC proto board material that I use, and it's connected and running, and I love it. I love it. Oh my God. I missed it bad while I was assembling the parts, moving them from the proto board to the PCB proto stock. It's beautiful. I've also got the parts, the miscellaneous electromechanicals ordered for that, the switches, the jacks, the plugs, all of that such. The colored LEDs in the color I choose to use. I hope you're well. Hope you hung in there with me. I don't know what I'm going to edit out regarding that little slip of mind, but I'll talk to you later. Take it easy, guys. Bye now. Oh, big stretch. Something was missing. If you want to say I love you, if you want to say bye to fellas, I love you. See you guys. Come back soon.